Imagine driving on a busy highway, and then you see an obstruction ahead. Suddenly, the three-lane highway merges into one. Now everything slows down and the traffic becomes unpredictable. Similar concept can be applied to our own cardiovascular system. When the cholesterol level in our blood becomes high, it will start to accumulate and cause a buildup known as stenosis. This disrupts the blood flow and lead to more cardiovascular problems such as stroke and heart attack. So, doctors might suggest a catheterization treatment where they slide in a thin tube through the artery to open up the blocked site. But if stenosis is like the traffic obstruction, then the catheterization treatment is like sending a roadwork into an already congested highway. While the catheter do treat the stenosis, at the same time, it causes an additional obstruction inside the artery. So the blood flow changes and become highly unpredictable in these conditions. So this is where my research comes in to analyze this unpredictability so that we can improve the catheterization treatment. Through my approach, I replicated these conditions using the mathematical models and the Herschel-Buckley fluid model. It is one of the fluid models that can replicate the blood behavior inside a very narrow space. So I simulated how the blood flows and how the drug disperses inside the artery. And using the graphs and data simulations, I observed the trends and identified the factors that affects the blood flow. Now, we can finally control the external variables. And by tweaking and changing these controllable variables, I can simulate hundreds of possible conditions until I achieve the desired outcome, which is an optimized treatment while also minimizing the risks. It's safer, faster, and it allows room for mistakes. Now, using this data obtained, we can stop guessing and start improving the treatment precisely. And using these simulations, doctors can visualize the patient's blood flow inside the artery so they can make better treatment plans. Not only that, we can also start designing more accurate medical devices and diagnostic tools. Targeted therapies and better drug delivery methods can also be developed. So through my research, patients now have more options and they can make informed decisions regarding their cardiovascular health.